In the global race to power the AI revolution, the single biggest bottleneck isn't really about chips or software, but about the grid itself. We're in the midst of a clash between the hyperspeed of data center development and a legacy electrical system that was never built for this kind of scale or velocity. The grid of the past provides a foundation, but the grid of the future requires a new layer of intelligence to actually function. So, how do we stop building for what if and start operating for what is? For years, the industry's answer has been decades long studies and billion-dollar overhauls. But what if the capacity we need is already there, just hidden under outdated assumptions? My guest today is Shanice Mohanani, who's the VP and Head of Strategy and Operations at GridCare. Spun out of Stanford, GridCare is helping utilities like Portland General Electric move past worst case planning to unlock gigawatts of capacity. They're creating the digital thread that gets data centers online in months, not years. So, Shanice, thanks for taking the time to connect.
Yeah, thanks, Jeremiah. Very excited to be here.
So, GridCare software is designed to unlock the potential of the existing grid in a way that allows developers to get up and running faster and allows utilities to better leverage what's available to them. At a fundamental level, how does your software find and leverage this kind of capacity that's, as we said, is already there?
Yeah, for sure. So I guess maybe I can take a step back and start with the need for it. Um, Many of us have seen Jensen's analogy of AI being a five-layer cake, with energy being the foundational layer of that. And so that premise shows us that any AI that has to get deployed first relies on the energy being available. And a lot of the folks who listen to this podcast already know that that demand is rising exponentially and way faster than the grid can keep up. So, although there's been a lot of discussion for around how the grid is super overloaded, nothing more can connect, we have to wait 10 years, or conversely, we have to send ships to space or invest in failed nuclear facilities, we think the fastest, cheapest, cleanest solution is by squeezing more out of existing grid infrastructure. And the core insight here is that the grid gets constrained only rarely and for very few hours. So, our co founders at Stanford published this paper that you might have seen, where we've shown that across the Western US, that's where the study started, even the most congested utilities have their grids running at between 19 to 35%. And so that shows us the scale of the potential that we're able to unlock. And our hypothesis is if the grid is running at 30% utilization and we can double the grid without building any new infrastructure, that's 300 gigawatts that we can unlock to power the AI revolution. And so just going back to your question around the AI models and the software that we've built, we first built a pre-trained AI model of the grid that we then fine-tuned based on real grid data to identify the exact time, duration, and geography of these events that occur infrequently, but then take up a lot of capacity on the grid. We run quadrillions of simulations, quadrillions, that's a big number. And that's only possible with the compute and the sophistication of AI models that's available today that allow us to see for every hour of every year over 10 years under every scenario what happens and what we can do to overcome those constraints. And so we've built the GridCare Energize platform as an end-to-end AI native data center activation and operations platform to specifically address these constraints that happen on the grid infrequently and free up, or as we call it, activate a lot of capacity that's lying latent on the grid.
Yeah, that ties into what I was going to ask you about how that solution, how what you've developed compares, or in some ways it could be superior to kind of traditional planning. Because that time, the duration, the geography, that's obviously factored into the traditional planning. But is it that compute power that makes the difference, or the kind of real-time data that is a factor in this?
Yeah, it's kind of all of the above. And I don't want to say anything bad about the planners because honestly, they have a really tough job. Their job is to keep the lights on. When the lights go off, everybody gets upset. And their job is also to continue to keep rates low for ratepayers by making sure that we're harnessing the grid appropriately while keeping it safe and reliable. I would say that it is primarily the advances in compute and technology that have allowed us to look at the grid in a way that just wasn't possible before. Our co-founder Ram, he's our CTO, he sits right next to me. He ran the lab at Stanford that was on the cutting edge of designing these systems and frameworks for how we can look at the grid in novel ways to harness more. And so some of that research has informed our approach, but I mean, the scale of advancement in AI has definitely been very helpful in being able to run these simulations much more quickly, much more scalably, and in a way that can be effectively verified.
So does your software actively control the utility and customer side assets in real time, or is it more about awareness, kind of arming those planners with the info they need?
Yeah. I mean, at the core of it, this only makes sense if there's an actionable and win-win outcome on both sides. Like, we don't want to force the AI infrastructure developers to do anything they don't like doing. We know that they don't like to be curtailed. And we don't want to force the planners to do anything that potentially compromises grid reliability. And so our algorithms are able to parse a very large search space across all of these scenarios to find the solutions that we think make sense to overcome the constraints. So, from a customer perspective, that might look like bringing on a battery or using more of their existing backup generation or being flexible with their compute. For a utility, that might look like looking at what all resources they have in their existing networks that they're not yet thinking about or incorporating into the planning cases. And when you have this really high fidelity view of what's available in the network and what the data centers are willing to do, we're then able to come up with the solutions that are appropriate for overcoming those specific constraints that happen on the grid under the scenarios that this data center wants to interconnect.
And I mentioned your guys' work with Portland General Electric up top, and there was a whole feature in Canary Media, which was great.
Yeah.
And your CEO is quoted in there, and one of his quotes just really stuck out to me, where he called out, why do we have to live with the old assumptions of designing around worst case scenarios? And you touched on that a
Yeah.
little bit earlier, but I wanted to dig all the way into that. And what does it mean to move away from that kind of worst case scenario planning and fundamentally change the day-to-day operations, and how can that impact, I mean, really the approach that overall that a utility can take to how they deliver power?
Yeah, so technology is one part of the solution, and we've built the technology. But I think the thing that's key to driving adoption is just the open-mindedness and willingness to solve the problem. We've been very fortunate that at Portland General, Maria Pope is quoted in our press release. She spoke about it publicly in her earnings call. But we've seen that level of buy-in and support right at the top across every utility that we've worked with. And I think we have to also tell the right story to make sure that people understand this isn't a black box and that if we do this right, it benefits the planners, it benefits the utilities, it benefits the system, and not just the data centers. So we wrote this white paper around how AI data centers can help drive affordability and capital investment. At the heart of the utility business model is, well, we make investments and we get paid a rate of return on those investments. If we use existing infrastructure more wisely to power all of this AI deployment that's going to happen, we've shown that in an average utility in the US, 1 gigawatt of new load can bring down rates by 5%, or it can accelerate $1.35 billion of capital investment without any impact to your or my electric bills. So again, framing it as a win-win solution and recognizing that technology can help drive that is then what earns us that senior stakeholder buy-in and getting the folks around the table who can collectively say, like, yes, this is something we should do, that's right to do from a systemic perspective.
Well, I mean, to say those topics are top of mind is kind of an understatement. I mean, the
Yeah.
affordability piece, I mean, that's bled into the mainstream, much less how those top affordability is a topic at events like DTech or things that we cover on the site. It is just it's just all the utilities are talking about lately. And then too, the data center piece is the installation of these data centers means the customers are paying for it. Like that's not the reality, but what does it mean for utility to get in front of that affordability issue, and what does it mean for utility to position and utilize these data centers as assets? Like that is just so key.
Yeah. And I think there are places where, candidly, we've overbuilt and ratepayers have footed the bill. And that's not great, but that's because we didn't know that there's a better way. In my lived experience working with the hyperscalers, data center developers, even inference providers and neoclouds who are now building, there's a recognition and a willingness to do what's right. And like people want to be good grid citizens. You just have to kind of show them the way. Google has a lot of great initiatives around this. Anthropic recently, went on record to say that they're committed to covering any grid costs that they are personally contributing to or resulting in because of their data centers. So, yeah, this is cheaper. Just use more of what we have.
Well, and that your mention of possibly overbuilding connects to what I wanted to ask you about flexibility and how it should be considered. Should it be considered as an alternative to hard grid upgrades? It sounds like the answer is probably yes.
Well, sitting in my seat, the answer is yes. And I think flexibility sometimes gets confused for curtailment. Curtailment is just brute force flexibility. And if you're running a cloud data center, being told that you just have to disappear at short notice is impossible because your SLAs don't allow for that. There's a lot of lost revenue opportunities for that. And so I think we have to move to a more nuanced definition of flexibility in a way that like makes stakeholders comfortable that it will not impact their business. And I touched on this a little bit earlier, but some of the sources of flexibility can come from the data center, and I would split that into two buckets. The first is infrastructure level flexibility, where you think of generation assets, storage, or potentially the movement of heating and cooling inside the data center. And then there's a second level, which is compute flexibility. And so we're seeing some companies in that space that can help data centers move load from one location to another or be more flexible, typically in the context of a training data center. But then on the other side, there's a lot of flexibility on the network already. Again, that we can't ignore because a lot of latent capacity is there. It's just not being studied.
Well, but even that distinction that you just called out of what it means to think of flexibility as distinct from or connected to curtailment, like all of that
Yeah.
is part of the utility's long-term strategy. And I mean, you touched on that with what Portland General Electric is doing, and now that they can bring 80 megawatts of data center on load online next year. And obviously, you
Yeah.
can't speak to their specific long-term strategy, but like those nuances impact what they can and can't do. And can you just talk a little bit about how these specifics can be part of that kind of long-term utility planning?
Yeah. And I think, again, technology is part of the solution. So with our AI models, we are able to look at all sources of flexibility that the data center is willing to bring and study the ones that already exist on the utility network that previously just weren't visible. Because even in a utility, planning and operations are two different silos. And we have been in situations where we've gone to a utility and they've told us, like, wow, we've never met the planning guys before. We've never met the operations guys before. But like fundamentally, those two have to come together. And then once we have a holistic view at the utility, the data center side also has to come together for us to be able to design these solutions.
I know we talked about those specifics with Portland General Electric, and that white paper is out there, and we'll include a link to that. But are there any insights or lessons learned from that project that you think others could easily leverage, or is there anything specific to that or that specific region that is specific there and isn't going to be indicative of what can work elsewhere?
Yeah. So Hillsboro, Oregon is one of the most congested data center clusters in the country, if not in the world. I think Northern Virginia may be more congested with Data Center Alley, but Hillsboro is where all the Pacific fiber cables end up. So you see all the big developers there, and they have offtake from the hyperscaler customers who need to be there. And even at Grid Care, our assumption going into this was like, wow, if we can crack this region, we can like go anywhere in the US or anywhere in the world. And I think it just gave us a lot of reassurance that even in markets where traditionally you would say like, man, this place is maxed out, there's a lot that we can do. We started with 400 megawatts. We think there's more that we can do. We are continuing our partnership with Portland. They've been very supportive. And now we are also partnering with utilities in markets that have historically been portrayed as very constrained. So National Grid, for example, that has the grid in New York and Massachusetts. And then Pacific Gas and Electric with their grid in California. Historically, markets where people have found it very hard to get capacity, and we're seeing that there's a lot of potential. I would add, though, that one thing that has been a tailwind is something our partners at NVIDIA are doing, which is helping propagate the idea of flexibility. They have a great Omniverse and DSX suite of systems where they show with their simulations how data centers or AI factories can be more flexible. And that like gives us more data points of what an AI factory energy footprint looks like. And so collectively, if we come together, we can continue to get the data that makes all of this possible.
Well, and starting with that concept, and that's another thing I wanted to ask you about. What you can say about the stepping stone process that defines the way you work with utilities, because I think in a lot of ways, we talked about how that impacts utility planning, and like there's just some big established processes and the way things function, and it's kind of, I don't want to say turning that upside down, but kind of a major change to it, and that doesn't necessarily have to be the case. So, in what ways do some of the smaller efficiency tests that you work with some of these utilities on, how can they provide a baseline that allows them a better sense of what it means to move forward and potentially change or start to change some of those processes?
Yeah, I have a hot take here. I think a lot of startups in utility world get stuck, and this speaks to my prior experience as a venture investor in the space, get stuck in pilot purgatory where you're trying to do small things to pave the way for big things. Grid care from day one, we've not really done things at test scale. Like we think that if this thing works, it should work on real projects. So across the board, in all of our engagements, these are at least tens of megawatts, if not hundreds of megawatts of projects that we've taken on that we are working on directly with the utility partners as well as the AI infrastructure developers. Portland, again, just to like go back to that, because it's the only one we've publicly announced, was 400 megawatts. Like those are real AI factories at scale. And we started there.
Swing and think big. I like that. I mean, but I'm
Yeah,
sure you've seen, and I mean that is out there. Like you can fall into
yeah.
that pilot purgatory, or even too, then things get siloed of what's working for a
Hmm.
smaller team or in a specific area, just literally won't work elsewhere. So I don't know if it's that middle ground or like finding, but then too, like then starting bigger as you're suggesting, because I mean we talked about, you touched on it up top, like the demand is real, like that's going to be needed.
Yeah. And I wouldn't necessarily say it's starting bigger, but I would say it's starting with a real pain point. Like nobody has time to waste on, sub 1 kilowatt or sub 100 kilowatt scale projects and take away real time from real projects that have to be interconnected. So typically, what we've been able to do is find projects where the utility and the customer have shown a level of commitment to getting this done, a level of openness about the way they build the data center to accommodate flexibility. And so when we have that starting point, then we need to make sure that we can do a lot of testing on the reliability side. We can help the utilities do a lot of verification of the planning cases that we activate, but it has to be real.
Well, and that makes sense. And maybe that is that middle ground, not necessarily that starting huge, but starting with that identifiable problem that is big enough and needs to be solved, but then approaching it in a way that solves that rather than just solving a small piece of that or a pilot in it.
Exactly. Exactly. Yeah, and I think like even NVIDIA AI R&D factory came online sooner and it helped bring down rates for you and me. Like we would be happy with that. So yeah,
I
let's
would
do that.
I would like to see that. That would I'm in.
Yeah, yeah.
Is there one development or trend in the energy sector that you're most excited to see take shape, or even anything specific to your recent projects that you think can scale or be utilized and leveraged elsewhere?
Yeah. I think the most important thing that has to take shape is understanding how these data centers can be grid assets instead of grid liabilities. In our energy circles, that idea has become more mainstream, but to the average American, it's still not. Like a lot of the press coverage is still extremely negative, but I think there's a lot of education that people like us and a lot of our peers are starting to do to show that path of like, hey, these goals aren't in conflict with each other. They're actually super aligned. So I'm excited to see more of that take shape. I'm excited to be able to announce more proof points soon and help contribute to the debate that like, hey, this thing can help you and me and not just help AI.
Well, that data centers as a grid asset, like the communication around that is something that's been top of mind for me. Like we have our data center and AI event coming up in May, and like that's going to
Yeah.
define one of the keynotes even. But to you, like, is it more about the utilities kind of driving that message, or more about the developers, or both of them in tandem? Like, where and how does that communication need, where does that need to come from? And then what's the best way to get it out? Is it about getting it out to the energy industry specifically, or does it need to go more wide stream, or maybe all that can be connected?
Yeah, I would say the answer is yes and. And I think the big stakeholder that has to be part of the story is the government, both federal and state. And I think the Department of Energy has been very supportive of us and our efforts in telling that story. And they have been looking for solutions to this problem and helping educate consumers about, well, one, the importance of low rates and how it's a shared responsibility to get there, but two, um, creating pathways for us to be able to show that. So I think with the government, the utilities, and the data centers, I think there's a responsibility to share a broader story beyond just our like tight-knit, very small data center energy group of folks.
Well, and it's because they're all coming to that conversation from different perspectives, and it's not that there
Yeah,
aren't overlapping benefits there, but what do those look like, and how do they
yeah,
overlap in a way that we can result from a conversation like that won't just happen.
yeah, totally agree.
Excellent. Okay, well, Shanice, last question for you. Tell me something powerful.
Ooh, okay. I think for me, it's the idea that the company we build is the product. Technology is one part of the product, but creating a business model that aligns incentives, responsibly engaging stakeholders, hiring people you love working with, and making sure that people who work here love being here. All of that is the product. The company is the product. And so I think for a product company to succeed, it's very much for us, or for me, beyond the, oh, our software is amazing, our AI models are the best, but it's like, can we build the company that tackles this problem at scale?
Yeah, and can you cultivate those connections and those relationships with folks that know they can rely on individuals rather than the tech? Because the tech is going to
Yep,
change, the tech is going to evolve, but what's the baseline that those folks and that industry can keep coming back to? So yeah, cultivating that
exactly.
relationship is key.
Yep, exactly.
Excellent. Well, Shanice Mohanani, I really appreciate you taking the time to connect. We'll stay in touch on all things grid care.
Yeah, thank you, Jeremiah. This is great. Thanks for having me.